Hello viewers and my dear students. Welcome to session 2 on problem 4 on analysis of beams. Here I'll be showing you a demo on beam with inclined loads using Ansys Release 14 of Mechanical APDL, and we'll concentrate only on obtaining bending moment and shear force diagrams. As you know, it is session 2. In session 1, I have concentrated on the theoretical part of it, how to get bending moment and shear force diagrams theoretically, and also I have shown you how to get reaction solution also theoretically. Now, in fact, in session 1, we already started with doing in Ansys also. Okay, we have come up to this. That means we have created the key points and under Gurdat beam inclined loads and all that. It's a new log file, and I have given the title as beam analysis subjected to inclined loads and all that. This you already know. Now, once you created key points, I'll continue now. Create lines, straight lines. You continue 1 to 2, 2 to 3 you do, 3 to 4 you do, 4 to 5 you do. Okay, then you just say okay. Okay, before you forget, then you go for meshing and all that. Before that, first we'll finish the section part. Section beam common section, as you know, in this, it is 0.2 is the width and 0.3 is the depth. B is 0.2, H is 0.3, you give, just say okay. Okay, now you have completed in this way. Now, as you say, section B modeling is over. Then we'll go for meshing. Mesh attributes. Okay, picked lines. You pick all these lines. Okay, default attributes. Just don't change anything because there is only one material, and this section is section 1. The real constant, what I just now defined, it is there here. Don't worry about the pick orientation key point. Don't touch this and all that. There is only one material. Okay, and that is beam. The element used is beam 188. You just say okay. Don't worry about that. Then we go for size controls. Size controls. Okay, see carefully. Lines, picked lines. I'll pick this, and pick this. I'll say okay. If I do 50, it will be 50, 50, 50, 50, 200. If I make 2500, if I make 10, it is 40 elements. Say, let us say number of element divisions, I'll make it 50 only. When I make it 50, it will be 200 elements. Okay, this will be 50, this is 50, this is 50, this is 50. In that way, mesh lines, pick all if you do, it is converted into 200, that is actually if you see this, 200 elements it would have created. Let's see here, just see here, the elements are here. If you see here, 200 elements it would have created. Okay, now we are going in the perfect direction till now. It is also no problem at all. Now once you do this, you here there is a small, because these are all subjected to inclined loads. That is why we have a small procedural change. Okay, plot lines you do so that you will know where exactly you have to do the change and all that. Here there is one inclined load. Here there is one inclined load. Here there is one inclined load. Here 100 newtons at 60 degree. Here 100 newtons at 200 newtons at 45 degree. Here 300 newtons at 30 degree and all that. This you should know. I'll show you the small procedure. Then modeling. Okay. Under nodes, no. Nodes. Rotate node in that is rotate node by angles you take. By angles you take. Okay. Now you see here, I'll enlarge this zoom model. Okay. At this point I'll take, I'll just say okay. Then there about vertical minus 30 I'll do. See here, if you vertical, this side is positive, this side is negative. If I take minus 30, it will create one force in the direction of 60 this way. 60 degree with reference to this. Minus 30 here, 60 this way. Anyway, you'll know shortly. Minus 30 I'll do. I'll just say okay. Okay. In the same way, I'll just fit it. Okay. Here, I'll enlarge the section. Zoom model. Here, also I have to do rotate nodes by angles. Here you do. Just say okay. And then there you do minus 45 you do. Minus 45 you do. Just say okay. You are rotating node by 45. Okay. Then again you fit. Okay. And zoom this. And here you have to have. Okay. Here you have to have 300. Okay, now you see rotate by angles. Here you take, okay, say okay, and here you do minus 60, so that with reference, if it is minus 60, there will be a force created in 30 degree. Okay, that's what I want. Okay, I just say okay. This is the initial thing what you have to make it ready before operating the boundary conditions and all that. You make it ready. Then loads you go, define loads. First you do fit, define loads, apply structural displacement on key points. You take this key point, say okay. See here, ux, uy, uz, rotation x, rotation y, all you arrest here. Okay, this is that. Then rotation, that is structural displacement on key points. Here you say this is a roller support. No, you have to allow x. Ux you allow. All other things let it be there. Uy, uz, rotation x, rotation y, all let it be there. But allow movement in x direction. This is let it be there. Say okay. Okay, that means there, here and here it is done. Now carefully here, I've already rotated the nodes. There, here 100 Newton should be in at an angle of 60 degree, 200 at 45 degree, 300 at 30 degree. See here, since I've already made that, now what I'll do, force moment on nodes I'll do, force moment on nodes. See here, as usual, I'll enlarge this. Okay, here I'll just say okay, F5 minus 100 I'll do. I'll just say okay. Can you see? This is, if you see this, it is at 60 degree only, acting downwards. It is okay. Then I'll just fit the view, and here I have to apply again 200 newtons at 45. Then I'll enlarge that area only. Carefully you see, I'll enlarge that area only. Okay. Now I'll enlarge that area. Structural force moment on nodes. You just see here what I've done. Just say okay. F5, you would say minus 200. Minus 200, you just say okay. Now you see here, this angle is at 45 degree coming downwards. Again, you fit the view. Okay. This is minus 200. Okay. Now, in the same way, zoom model, here you take at this minus 300 at 30 degree. Okay, force moment on nodes, since it's already rotated, automatically it takes care. Okay, say force moment on nodes. You select this node and say okay, and say it is minus 300. Minus 300 you say. Let's say okay. Now this is also you got. Now you fit all that. Okay, plot, multi-plot if you do, it is perfectly done. This is 100 newtons at 60 degree. This is 200 newtons acting downwards at 45 degree. This is 300 newtons acting at 30 degree. Okay, to the that is the beam section. That is for beam section. This is 30 degree. This is 45 degree. For beam section, this is 60 degree. Okay, in that way, the loads applied, everything is correct. Now what I'll do is, once this is done, solution, solve, current LS I'll do. I'll just say okay. Then solution is done, is that? That means you are in the right track till now. We have got the proper procedure. Everything is okay. Then you immediately see here. Once this is done, the first thing what you have to check is general post process. Okay. General post process. List results. Reaction solution you observe. If you have made mistakes, it will be reflected here only. Okay, say this you see 173.16 and 204.86. This you see here what you got reaction solution, whether it is okay or not. See here 173 and 204, it is perfect here. In that way, what you have done till now is correct. 173 and 204, it is proper. Okay. Then you just say close. Okay. Then you go for element table, define table, okay, add, and as you know here, by sequence number, SMISC 6 apply, SMIC 19 you apply, okay, and by sequence number SMIC 3 you apply, SMIC 16 you apply. Okay. Now, as you know, 6 and 19 will give us the shear force diagram, and 3 and 16 will give us bending moment diagram. Okay. Just stay close. Okay. Now, what you have to do is, once you do this, plot results you go, contour plot, line element results. Now, you see here, 6 and 19 if you go, you should say, you should get shear force diagram, and it is this way. This is, you see, 204.861 here, okay, and here it is 173.163. This you immediately compare with your theoretical solution, okay. What you got, you see here, 204, this is 173, this is 86, 54.85 and all that, this you know. At least you compare the extreme ones, 204 here, minus 173 here, you just see whether you got the same thing here. 204 minus 173, it is perfectly been done. It is clearly done. And now, as I told you, this also plot controls and rate meta file, invert white and black. In that way, this is a very important solution. What you have to show it in your record or even in the exam, this plot has to be shown to the examiner. Okay, this is very important. In the same way, line element results, then you go for 3 and 16. This you say okay. Then as you see here, the maximum bending moment, red you see, it is here to here, straight line, straight line, straight line, straight line, what we have already got by theoretical method. The maximum bending moment what I got is 259.174. That also you verify here whether you are getting the same thing. Okay, you see here 259 point something is the maximum bending moment. Here 204.85, 173. But the maximum bending moment is 259.64. That is exactly matching with this. Can you follow? 259.174. This also plot controls, write meta file, invert white and black. Okay. In that way, you take this also plot and show it to the examiners. And I'm telling you the important things what you are doing here is list results, nodal solution, list results, reaction solution, all items. This is one thing what you have to show it to the examiner. This is very important, or you record it. Okay, you make a tabular column and record all these values. These things 173.16 and 204.86 matching with the theoretical ones. Okay, in the same way, you go for element table data. Okay, that is plot results, contour plot, line elements results. 3 and 16 will give you this bending moment diagram, which you verify, which has been verified. This also you are giving it to the examiner and writing it in the record. And also 6 and 19. 6 and 19 also you give it. Okay. In that way, all things have been verified. Okay. Okay. Now we have come to the end of session 2. Session 2 on problem 4, analysis of beams with inclined loads. Okay. Thank you friends for watching. We have completed this problem. In the next sessions and all that, we'll start with the finding out bending stress, how to get bending stress for the same problem and all that. Okay. Thank you very much. Thank you for watching.